All right, so we are continue to study elementary mathematics. Last semester we covered 15 lessons plus one review class. So today's lesson is lesson number 17. We are going to study counting figures. Okay, before I do that, let's have a quick review how to find the sum of those arithmetic sequence. Okay, so we begin with 1. Yeah, we begin with 1. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, suppose it's plus 10, right? How do we add them together? Okay, maybe you memorize some formulas later, but if you don't remember any formulas and to add them together, you cannot do 9 additions. That takes too much time, right? So the idea is you reverse the order. You reverse the order and all the way to here, 10, right? And then 9. So add them together, you double the sum. If you double the sum, you can add them together in different way, like 10 plus 1, it's 11. And then 9 plus 2 is 11. And so on. You find out every term is 11. Then how many 11s there? That's 10 times 11. But to get the answer, you already double the sum, so the answer should be 10 times 11 divided by 2. So the first one is the number of terms. The second one is the sum of the first term and the last term. Look at 10 plus 1, right? Yeah, 10 plus 1. So actually the formula you are going to have is always the last term plus the first term, and multiply by the number of the terms divided by 2. Yeah. So how do we get that formula? You can look at that. We double the sum, reverse the order of those numbers, and then you add those two numbers on the vertical line, and that the sum is actually the first term and the last term. Okay, and then how many terms there? Right, have 10 terms in this case, and you multiply them out, and you get it answer. Okay. Yes. All right, so it's going to be 55, as long as you know how to do it, then you get an answer quickly. All right. Why do we want to study this? Okay. Next problem is to count. How to count? Yeah, let's count the line segments. Okay, this is today we're going to do. So let me begin with the geometry problem. Okay, I have a straight line. Okay, I put it. Yeah, this is cut into how many pieces? 3 pieces. Yeah. The question is how many line segments are there? Okay. Now, how do we count? Line segments can be this. This is also a 1 line segment. Okay. Okay. So it could be 1 segment. So yeah. So line segment means the line segment can, 2 end points will be those 2 dots. So it could be 1, 2, 3. The first number 3, right? Then you start from the second point. 1, 2 plus 2. Then the last one is 3. So you get all the possible line segments. So the sum is, you can add them directly. You can also do the following: the number of terms times the sum of the last term, and the first term, and divide by 2. So it's going to be 6. Okay. And yeah, let's do one more problem like that. Okay, I have 1, 2, 3, 4. Okay. So still the same question: how many line segments? Okay. Now, line segments by definition is could be any of those, as long as you're letting mark it. This is one of the line segments, okay? This is one of the line segments. Yeah, please take shoes off and find a seat. Thank you. All right, so this is a line segment, okay? So question is how many of them? The two end points of the line segment will be the two dots, okay? Will be just two dots. Okay, any pair of dots determine one line segment. The question is how to count them, okay? And how to count them, you do like that. For each of line segment, don't repeatedly count them, okay? So for each one, the first point, you count it like that. 1, 2, 2 means this line segment consists of those 2 points. 3, 4, 5. You draw the picture. So the first one is 4. Okay, you get 4 line segments. The size are different. Okay, the next one, yeah, please take a piece of paper and a pencil out, and sometimes I will ask you to do it in class. Right, then you use a second point, but don't go back because this is already counted, right? This is the direction. Don't repeat it. So the only way you can go is go further. 1, 2, 3, 4. Right? So sorry. 1, 2. Yes, this is 5. The first one is 5. Okay. 1, 2, 3, 4, 5. The second one is 4. Okay. All right. So you have 4 points, right? Then the third one, this 1, 2, 3, 4, 5, 6. So you can find a pattern, decrease the number by 1 each time. So from the third point, you can only go further. 1, 2, 3. So plus 3. From the fourth point, you have a 1, 2. So then the last point is 1. Okay, and you get the sum of those numbers, right? You get the sum of those numbers. You have to add them together. Now, if you only have 5 numbers here, it's easy to add them, right? So this one, it's going to be 15. It's quickly can add them together if you know how to do addition. But what I told you last time is the formula. Here's the number of the terms times the sum of the first term and last term and divide by 2. Okay, then you simplify and you will see 5 times it's a 6 divided by 2. Now 6 divided by 2 is going to be 3. You cancel, right? Because 2 times 3 and then 2 cancel out and you get 3. So that's what 3 times 5 is 15. Yeah, you don't need the reason I want to know this formula is because you may have 100 terms and you cannot just add 100 times. That's right. I increase the number of the points more. For example, yeah, I have like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Now, still the same question. Yeah, how many line segments are there, right? So, yeah, we do the same way. From the first point, you count how many of them, and then because you have a total 11 points, and then you get from first point, you get 10 line segments, okay? Because 1, 2, you cannot count the first one, right? So from 2 to 11, you have 10 points. Each point gives you the line segment from the first point, okay? So total 10. Then from 2, you have to go further. You cannot go backward because from 2 to 1, it's already counted, okay? We are not, the line segment is not oriented. They're almost forward, okay? Then you get, yeah, from 2 to 3, and from 2 to 4, from 2 to 5, and then you keep going. Total how many? 9, decrease by 1. And then from 3, you go further, forward, and you get 8 line segments. From 3 to 11, you can count, it's get 8. And keep going, and if you find a pattern, you don't need to do all of them. Just say, hey, I'm decreased by 1 each time. So get 10, 9. Now, how to add them together, right? At the very beginning, I already did it. How to add them together, right? How to add them together, you have 10 numbers here. You cannot do 1 by 1. So the best way to do is use a formula. The numbers of terms, which is 10, times parenthesis, which is inside the sum of those two numbers, and that will be 10 plus 1, and divide by 2. Okay, that's a formula. Okay, then you get 10 times 11 divided by 2. How to do this? You know, you don't. Yeah, the best way to do is simplify first before you do the division. 10 is 2 times 5, so 2 cancel out. Then you only get 5 times 11. 5 times 11, you know how to do it. You don't use the calculator, and then this is 55. Okay, so there are 55 line segments there. Okay, and why we want to do study like that? For example, this is a railroad, right? You have 11 stations there. You want to print out the tickets, right? Tickets, you know, so a pair of the points, a pair of stations, you have one ticket, okay? So the question is how many different type of tickets you have to print? So that's a real problem, right? So you have to print out 55 different tickets. On each ticket, like, oh, Indianapolis, Chicago, right? And, you know, of course, we don't count the direction. Otherwise, you have to double the number of tickets, because from Indianapolis to Chicago, Indianapolis should put on the top, Chicago second, and then revise it, Chicago first. Then you have to, you cannot count this way. I'm talking about, we're not going to tell the orientation, you know, then this is how many different tickets you can print out. If you're around this line, there'll be 11 stations there, and this is how to do it. Because each line segment, you have to print out one section, or one ticket, one type of ticket. Of course, you have to print many, but when you design, and this is how many different tickets have to design, right? And maybe each of them have to print out thousands, because it's so many passengers. Okay, that's the reason we want to study, you know, yeah. But we have to know how to add those numbers together. Let me repeat again. Why we use this? How do we get this formula? Okay. For example, if you want to add, okay, all together to 2020, how many terms there? There are 2020 terms, right? And you cannot do one by one, because then you can easily make mistakes. And after 1 hour, you're tired and you stop, you make mistakes, and the rest of them are all wrong, right? So you have to find a good way to do that, right? Let me repeat again. Well, how do we get this formula? And why this is like a number of the term times the first sum of the first term and last term, y divided by 2. Let me explain to you again, because some students maybe never heard about it. It's a new student. So, so what I'm going to do is I reverse the order, double the sum. So reverse the order, and the last term here is 2020. So I have 2 rows of numbers. Okay, so I double the sum, right? If I add it all together. But then when I add all those numbers together, I decided to add them in this way, on the vertical line. And then you see that, right? The first number times first term plus last term, 2021. But every time we get 2021, 2021. So how many terms there? 2020. So the numbers of 2020, yeah, add them together. 2020 times each number. The numbers are all the same to 2021. But if we just want to find the sum of the first row, right? As the numbers in first row, you have to divide by 2. That is the reason you get divide by 2. Sorry. Okay. So here you don't divide by 2. But if you just want to find the sum of the numbers in the first row, you divide by 2. Okay. This is this works for all mathematical sequence. Even you know, even not begin with 1. You can begin with a 10. You know, begin with a 10 plus 11 plus 12 all the way to 23, right? Add them together. If you use a formula, that will be how many numbers here? How many? How many numbers here? 14 or 13. How many numbers there? How do you count? Okay, you cannot do the subtraction 23 minus 10. That's a common mistake. 23 minus 10 is not going to be the number of the terms. Yeah, must be 23 minus 9, which is 14. And the sum of those two terms, 10 plus 23. Then you have to divide by 2. That's the formula, okay? And I already explained to you why we have to divide by, let me repeat again, yeah. So this is what we get. And then say 14 divided by 2, you can say 2 times 7, that's what 2 cancels out. So 7 times 10 plus 23 will be 33. Then you do the multiplication, you can get an answer, okay? I'm not going to finish that part. You can do by hand, okay? Now, why 14 here shows up? Because the same idea, if you reverse the order, yeah, and here's 23, here's 22, right? So you double the all the numbers, right? But when you add them together, you can change the order to add them together each time. Like 23 plus 10, you see, this is how do we show up, right? This is 23, and it's here. This is 23, right? Yeah. So 23 plus 10, be 33, and the same here. 22 plus 11, 33, and here 10 plus 23, 33. So all the numbers are 23. The question is how many of them? And you already got figure out 14 such numbers. 14 times 33 is a total sum. But that's for the double of these numbers, right? So if you just want to find the sum of the first numbers in the first row, you have to divide by 2. Okay, that's the idea. All right, let's continue. Go to the geometry. Okay, this time I'm going to draw this line. Okay, here's 1, here's 2, here's 3, here's, and I probably just added one more point. All right, so the question is, again, how many line segments are? Okay. All right, just slightly different, right? So the line segments are those. This is line segment, right? It also be those, could be, right? So those are the line segments. You have to find out. You have to print out, okay? Yeah, so it'll be strict line, okay? You cannot make a turn. So this is different. If you want to print the tickets for those stations, and then the problem will be different, okay? If we have, but we just only talk about strict line segment. All right? You already get it? How many? 9? Any different answers? Use a pencil and work on a piece of paper and try and figure it out. All right, so we can do separately. So first of all, this one, 1, 2, 3, 4. Okay, and we only talk about strict line segments. Okay, so another one is this. So just need to add them together. Okay, so the first one is 1, 2, 3. So we begin with 3, then 1, 2, 2, and 1 plus 1. You get all the possible signals. Okay, so total 6. And here is 1, 2, 3, right? So it's 3. Okay, so actually it's 2 plus 1. It's going to be 3. Add them together, 6 plus 3 equals 9. Okay. So basically just separate to do them and then add them together. Now, if this is just those are stations on the railroad, and then you want to print out the tickets for all the pairs of stations, then it'll be different story. It's not a line segment, it can go from here to here, right? So it's more complicated. Okay, so you can think about that. I'm not going to talk about this. We're only talking about line segments. Yeah. So how many pairs of points you are going to get? from this picture. Okay, that'll be different. Okay, it's difficult. Some of you maybe can figure it out. You can tell me later. Okay. Yes. All right. My next problem is a triangle. Okay. So in the large triangle, already draw 2 lines. My question is, how many triangles there? Right? How many triangles there? But let me show you a picture. The triangle could be this one. Okay, this could be one of the triangle. Can you count? You got 6. You also got 6. How about this girl? Again?
6.
Oh, can you take piece of paper? Do you have any piece of paper? Come on. Huh? You have nothing in your book bag?
That's 6.
Okay. All right. So here's the point. We can convert this problem to counting pair of the points, because this point is fixed. Okay, this point is fixed. So any pair of the points at the bottom line determine one triangle. So this pair, okay, determine one triangle, right? So the number of pairs of points, actually you just count how many pairs of points, because every pair of points determine one triangle. So you just need to count the numbers of pairs of points. You just need to count the number of line segments. So how many line segments here? You have 1, 2, 3, 4 points. So first one is 1, 2, 3, right? 1, 2, and the 1. It's always like that. It decreases by 1 each time, so it's total 6. So there are 6 pairs of points, or 6 pairs of line segments. 6 line segments, sorry. So each line segment determines one triangle. You converted the problem counting triangles to counting pair of points, to counting line segments. All right. So there are 6 line segments in the base line, okay, on the baseline, okay. So each line segment determines one triangles, right? So that's why in mathematics sometimes you have to change the problem to another equivalent problem that helps you to solve it. Okay, so total will be 6. Okay, the answer is 6 because each pair of the line segment and determine. Now we can increase the number. Okay, this actually was a problem even for middle school kids math competition. I tell you, I remember there was a student who missed this problem even. Yeah, never learned it before. But we now sounds easy. It's easy. Sounds difficult. If you never see that, it's maybe difficult. So let's add one more. Let's add more triangles here. Okay. All right. So that was the problem for the middle school kids competition. Like how many triangles there? Okay. How many triangles there? Okay. So as I told you, let me draw the typical triangle. Okay. A typical triangle could be like this. Okay. Okay. So we have a one. Yeah. So total is 7 points. Right. Now this is equivalent to saying 1, 2, 3, 5, 6, 7. Right. So a pair of line segment. So you can convert the problem from counting the triangles to counting the line segments. Okay, to counting line segments. Then how many line segments on this line? You have 7 points, right? To count them, you can do like this in order, like 1, 2, 3, 4, 5, 6. So 6. But does not include the one from 2 to 5. Don't worry about it. If when you start from 2, 1, 2, 3, 4, 5, right? Sorry, 5. So you get, yeah, the next round, you do get the one from 2 to 5. So it's a 5, and so on. And you get all of them. Okay? You get all of them step by step. You start from each point, you go further, forward, go forward to draw the line segment. And every time you get will be a number one less than the previous number. So 6, 5, 4, 2, 3, 2, 1. Add them together, this is the total number of line segments. Right? And how to add them together? Now it's hard. You have a 5 plus here. So the best way to do is how many numbers terms here? 6. And then the sum of the first term plus the last term divided by 2. So it's going to be 6 times 7 divided by 2. Don't do the multiplication first. I suggest you to 6 divided by 2, which is 3. Okay? Because 2 times 3 is 2 cancel out. Will be 21. Okay, split that. So 3 times 7, nothing is in the denominator. That's called simplification of a fraction. Okay? The fraction. Let me talk about fraction first. Okay? How to simplify fraction. For example, 42 divided by 3, right? How do 42 divided by 3? How to simplify? You can do the division. 42 divided by 3, right? This means 42 divided by 3, right? No problem. You can do the division. Many of you can do the division. But it also can be do like that 3 times, 2 times 21. We call it factoring. Okay? It's still not gonna. And then 21, you find out, oh, 21, I know 3 times 7. Then you say, oh, there's a 3 there. Okay, so cancel out. If you cancel out, there's nothing left in the denominator, just 1. Okay, so it's on the top. It's going to be, 2 times 7 divided by 1 is still just 1. Just 2 times 7, and then you get 14. So this is we factor the term, factor the number, then cancel the common factors, and then simplify the number. Of course, you can also do this. You already learned how to do the division. Okay, 4 or 1, 3, right? And you have 4 minus 1, right? And it's 2. And then, okay, 12. And then 3 times 4 is 12. Again, remainder is 0. Okay, so sum is 14. That's a different way to do. But sometimes we don't want to end up like that. We do want to simplify the fraction. Otherwise, you get a decimal numbers. Okay, if it's not divisible. Okay, so this is a quick review on the division. All right. Okay, so now we can deal with many triangles, right? Not only just the simple one here. But let me try again, we'll change a little bit standard one. Okay, so 1, 2, I draw the line here. Okay, so still the same question. How many triangles you can see in this picture? Okay. How many triangles? Well, triangle could be like this. I just tell you this is a triangle. Okay, I just give you, otherwise you confuse it. If we cut it in the middle, it cannot be triangle. No, this is still called a triangle, okay? As this is a triangle. Okay, and those are the triangles. This is the triangles. I just color them, just give an example. All right, please do that. It's not many there, many triangles there, right? Do you have answer? What is answer? You get 15. Oh, 10. You get 15. Let's see, what did they get? So Nina, what do you got? 12. Crystal, do you have answers?
Yeah.
12. Crystal said 12. You got 17.
No.
Alan says 12.
12.
Sophia,
18. 18.
you have 18.
Yeah.
Come on, can you take a piece of paper out and use a pencil, work on this picture, okay? I don't believe your your brains can work so complicated problems without writing. All right. All right, so the idea is that how do we determine the triangle, right? And here's another small one. Okay, actually, it's nothing wrong here. Actually, you only have two types of triangles. Okay, one is the short, smaller ones. Those. All right. So all I have to do is add them together. You count the number of triangles in each triangle, right? So here you see how many points here. 1, 2, 3, right? 3 plus 1, 2, 2 plus 1. So in this large triangle, before you put the line in the middle, right? And you have 6 triangles here. But the same here, you have 6 triangles. 3 plus 2 plus 1, 6. Okay. So total is going to be 12. 6 plus 6 is going to be 12. Okay. It's just nothing. No. Okay. And then you can do the same here. If I have a 1, 2, 3, and I draw a couple lines. Okay, let's do this again. How many? How many triangles in this picture? Right. All you have to do is to count the triangles in this one picture. Right. Then multiply by 3 maybe. Why? Because you have 3 different type of triangles, right? And the third one is like this. Right? Remember, right? And they are all similar. Topologically, we say that's the same triangle. Geometrically, that looks slightly different. But when you count the triangles, then you do the same way to count. Doesn't matter the shape of the triangles. Okay? 45, 30. See, how people get different answers. 45, you must do 15 times 3, right? Are you sure you double check how many triangles in the one larger triangle? Do you have answers? No? Are you done with that? You don't have a pencil, come here. Okay. You have 45, some got 30. Okay, let's do this. Like, how many triangles in the first one? Right? Actually, there are 3 identical. You just need to count all of them. You know, so this is going to be this is going to be 1, 2, 3, 4, 5, right? So when they do that, 1, 2, 3, 4, 4, right? And then 1, 2, 3, right? 3, and then just keep it going. That's all you get. It's 10, right? 10. So when each triangle you get 10 triangles. You have 3 different triangles here. So here's 10, right? So it's the same. So 10, 10. Add them together, right? 10 plus 10 plus 10 is going to be 30. Okay? Okay. Now, one slightly different, right? Because I hope everybody knows how to do this problem. Okay, I only draw 2 lines, but this time I draw this. Yeah, how many triangles there? All right, count. How many triangles? My hint is the triangles only coming from this one and the another one. And just add them together, right? Yeah. Right? Then no other triangles. Oh, wait a minute. Wait a minute. I made a mistake. Yeah, sorry for that. Sorry. Those are the triangles are vertical. We forgot this. Let's go back to here. Okay, let's go back to here. Did you miss anything? Right? 6 is, those are triangles are vertical still there. So there was another, you see, we already draw this line here. Okay. Yeah. Oh, that's include that. Yes. Yeah. The larger one is already included. Yes. Okay. So let's look at it here. Sorry for that. So let's look at it here. Yeah, this is also triangle, you know, that, but that's included in here. Okay. Yeah. So here, how many triangles do we get here? 1, 2, 3, 4, right? 3 plus 2 plus 1, 6. Okay. But how many points here? 1, 2, 3, 4, 5, 6, 7. Okay. Right. So so from the first point you get 6 triangles. So 6 plus 5 plus 4 plus 3 plus 2 plus 1. Add them together. Right? If you don't know, then you can do this formula using this formula. So it's been 21. Okay, 21. The sum of the first number, the last number, multiply the number of terms divided by 2. So the total is going to be 6 plus 21, or 27. Yes. All right, so this is about the triangles. And then now we are going to do the following. Okay. How many rectangles there? How many rectangles? Okay, a typical rectangle will be this. Okay, can you count? Now, how many rectangles there inside this picture? Yes. 10. Right, so this is similar to counting the triangles because every pair of the points gives you one rectangle, right? Every pair of the points gives you one rectangle. So that is going to be, how many pairs there? So 1, 2, 3, 4, 5. So you get, 1, 2, 3, 4. 4 plus 3 plus 2 plus 1 is going to be 10. So 10 pairs of points. Each pair determines one rectangle. Then you get 10 rectangles. Okay. Yeah. And that's fine, right? Now, so I can increase the number of the rectangles here. No problem. I can increase the number of rectangles. Okay. Yeah. So if I have a very long line, 1, 2, 3, 4, all the way, I assume that, yeah, just like that, right? And then you have to need to count how many points. Okay. I still have the same question. In this picture, you have to mark it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So you begin with the number. You see, if this is the first point, from first point, how many line segments you're going to get in the bottom? You get 10. Then from the second point, you get 9 line segments because 1, 2, 3 like that count. So 9. So you decrease the number each time. So you get all of them. Okay. You don't need to write down all the numbers. But how many terms there? 10. Okay. And the sum of the first term and last term will be 11. And you divide by 2. So the answer will be 55. Okay. So that's 55 rectangles. That's easy. Now, before I do the next problem, I want to introduce, we are not going to add them together. We'll do the multiplication actually. Okay. So if I list all the numbers, yeah, let's say, I'm going to use a parenthesis. Okay, 1, 1, 1 and 2, 1 and 3, 1 and 4, and then here's 2 and 1, 2 and 2, 2 and 3, 2 and 4, 3 and 1, 3 and 2, 3 and 3, and 3 and 4. So my question is, how many pairs of numbers there? Right? How do you count? The best way to do your count is, depends on how many rows, how many columns. Okay? From here to here, you have a 3. From here to here, you have a 4. Okay? So in each row, you have a 4. How many rows? There are 3 rows. Total, you get 3 times 4, the 12 numbers. Okay? So how do you count? You count the number of the pairs, number of the points in each row. Okay? Then you multiply by the number of the rows. You get a total. That's it, right? Right. Each row there are 4 pairs of numbers, and each column there are 3 rows. That's 3 times 4. That's gives you total. You don't need to count one by one. Okay. You can count the number of the rows, number of the columns. Okay. So if the first number, yeah. So here's another similar question. I have a 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. All right. I want, yeah, each of them are unit square. Okay. It's consisting of unit squares. Okay. My question is, how many unit squares there? Okay. unit square. Be careful, it's about unit square. Okay, not how many squares. How do you count them? All right, you do the multiplication. You don't count all of them because you look. What you do is you count in each row how many squares there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So first row 9 square. The question is how many rows there? 1, 2, 3, 4, 5, 6. So total will be 6 times 9, right? And then 54. Okay. Right? So 54. Okay, that's the way it is. So we do multiplication. You count the numbers of rows and numbers of columns, and you multiply them together. 54. All right. Now, here's a challenge problem. Okay. How many rectangles are there? How many rectangles are there? Okay, let me draw the typical rectangle for you. When you count them, this is a rectangle. All right. This is also a rectangle. You know, just give you some examples, colored. This is also rectangle. All right, those are the rectangles. The number you want to get must be divisible by 3. Otherwise, it's wrong. Aline, do you have answer? Put the hands up if you have answer. Okay, you already have answers? What do you got? Huh? You got 30. Yeah. You got 30. Any different answers? Yes. You got 41. Did I say divisible by 3? 41 is divisible by 3. That's my hint. Yeah, this is a challenging problem. I give you half more minute to think about that. Okay. Okay. I'm looking for the different answers. Nina got 45. Second time. She gave me 30 first. So there's some reason she changed mine. Kylie. Okay, so let's do this. All right, first of all, let's see. How many points at the bottom? 1, 2, 3, 4, 5, 6. Okay. So I want to, okay, I want to determine how many pairs of the bottom line. How many pairs here? How many pairs at the bottom line? Here's 1, 2, 3. Okay. So how many pairs on the bottom is? It begins 5. 5 plus 4 plus 3 plus 2 plus 1. What is that sum? 15. Okay. So there are 15 pairs of points on the horizontal line. How many pairs of points on the vertical line? 3. Why? Because 1, 2, 1 from right, and then another one. The 3 pairs. So you have a 3 pairs of horizontal line, 15 pairs of vertical line. Okay, 3 pairs of horizontal line and 15 pairs of vertical line. Right? What I want to say that 1 pair of the vertical line, 1 pair of the horizontal line determine a rectangle. Do you agree? Like this one. These 2 vertical lines and these 2 horizontal lines determine a rectangle. So how many combinations you're going to get? 3 horizontal lines, 15 pairs of vertical lines. Total 3 times 15 combinations. 45. You're going to get 45 rectangles. Okay, not 30. The reason you got 30 is you only double it. You only count the rectangles on the top, rectangles at the bottom line. Okay, bottom. There are 2 rows there, right? But then also, like the yellow one, it's occupied 2 rows. Okay. All right. So, yeah, let's get this idea. Yeah. How many rectangles in this picture? And now you get the idea, right? You just needed to count the number of pairs of horizontal lines. Okay, sorry, I have to respell it. The numbers of pairs of vertical lines. Oh. All right, so let's count those first. All right, so you have a 1, 2, 3, so 3, 1, 2, 2, 1, so 6. So you have a 6. You also have a 6 pairs of vertical lines, right? This is 6 pairs of vertical lines. You have 6 pairs of horizontal lines. Okay, total also 6. So what I want to say that a pair of horizontal lines, a pair of vertical lines uniquely determine a rectangle. This is a rectangle determined by those 2. See, so a pair of vertical lines, a pair of horizontal lines uniquely determine rectangle. So how many pairs of vertical lines? 6. How many pairs of horizontal lines? 6. Total combination would be 6 times 6. That's right. Yeah, that's right. So it's a multiplication and not addition. Okay. So there are 6 times 6 combination. Okay. So that means 6. Yeah. 36 rectangles. Now you got it, right? Yeah. So All right. Yeah. So we can do lots of other problems now. Okay, let's try this. 1, 2, 3, 4. Okay. Okay, let's do this again. How many rectangles in this figure? Okay, please do it. You just need to count how many pairs of vertical lines, how many pairs of horizontal lines, because a pair of vertical lines, a pair of horizontal lines determine a rectangle, right? Okay, this is a pair of vertical lines. This is a pair of horizontal lines. Okay. So those pairs of vertical lines, horizontal lines determine which triangle, which rectangle, determines this rectangle, right? So this rectangle is determined by, yeah. So you needed to count the number of pairs of horizontal lines and the vertical lines. Okay. So let's count how many vertical lines. 1, 2, 3, 4, 5, 6. So total number is, okay. How many pairs, right? So from, it's a 5 plus 4 plus 3 plus 2 plus 1, which is going to be 15 pairs, okay? Horizontal lines, we're going to get, yeah, 1, 2, 3, 4. So you get 3 plus 2 plus 1, 6. So we get 6 pairs horizontal lines. So total will be how many combinations? You know, you have to do the multiplication when you do the combinations. Okay, I just had to as to show you, you know, before. So it will be there 6 times 15 rectangles or combination. Okay, so what is that? 90. 90. 90. Okay. Good. 90, right? Evan got answer 90? Good. Okay. Sophia did get answer? Okay. Anyone online get a 90? Let's see. Okay. 90. 90. Great. All right. So today's topic is about counting. Okay. I haven't, but I'm not going to talk about the following problem. I leave this one for you to think about. Okay. So this will be a slightly different problem. I draw 1, 2, 3. Okay. 1, 2, 3, 4. Okay. This consisting of unit squares. But this time I'm not going to ask you to count rectangles. I'm going to ask you to count how many squares there. Okay. This is the number of the square be less than the number of the rectangles. And that is a question I leave to you to think about. Okay, I'm not going to talk about that. Okay, I just want to tell you square like this. Okay, cannot be rectangle, consists of 4 squares put together. Okay, this will be a different way to think about it. Okay, yeah, maybe you can figure it out. Okay, do your best and just have to think about and find a way. Okay, so that's it for today's class. See you next Saturday.